So let's paint a picture. You're the lead architect for our favorite imaginary company, Wide World Importers.
Mm.
You've built everything out on Azure, web apps, load balancers, the whole 9 yards. It's all sitting there, ready to go. So you pop over to your registrar, you drop, what, $12,
Hmm.
and you buy the domain,
Mhm.
wideworldimports.com.
The fun part, right?
You think so. You type it into the browser, all excited to see your shiny new website, and it just nothing.
The classic, the browser just hangs, or you get that generic page not found.
Exactly. It's that disconnect. You've bought the name, but you haven't actually told it where to go.
You haven't connected the identity to the infrastructure.
Right. And that's what we're digging into today. We're looking at Azure DNS. And not just, what is it, but how you actually bridge that gap between the registrar and your stuff running in Azure.
Yeah.
And I have to say, my first thought looking at this was, why bother? Why not just leave DNS with the registrar?
That's the right question. GoDaddy, Namecheap. They all give you a DNS manager for free.
Yeah. It feels like you're creating extra work for yourself, migrating it all over to Azure. Is there a real technical reason, or is this just, Microsoft wanting you to live entirely in their portal?
Well, for a simple site, maybe it doesn't matter, but the case the sources make is really about reducing what they call friction in your control plane.
Friction. Okay, so it usually means something is slowing the dev team down.
Exactly. I mean, think about your workflow. If you're
Yeah.
building on Azure, you're probably using ARM templates, maybe Bicep, Terraform.
You're automating everything.
You're automating. And if your DNS lives in this totally separate silo on some registrar's website with a shared login and no API, you've just broken your automation chain.
So every time I spin up a new test environment, I have to stop, manually log into a different website, and go create an A record by hand.
Right, and you're probably sharing that login with 3 other people, which, makes your security team just scream.
Okay, that makes sense.
Hmm.
Moving to Azure DNS means it's all under the same role-based access control, the same RBAC as my VMs.
It unifies the management.
All right, so I'm sold. We want to bring wideworldimports.com into the Azure fold. The process starts with creating what's called a DNS zone.
Right. And we should probably clarify that term because it trips people up. The zone isn't the domain name itself. You can't buy a domain from Azure.
So Azure's not a registrar.
Generally, no. You still go buy the name somewhere else. The zone is just, think of it like a file cabinet. It's the container in Azure that's going to hold all the records for that specific domain.
And the docs really stress putting this zone in its own dedicated resource group. Why is that so important?
It's all about lifecycle and, frankly, safety. You don't want your corporate DNS zone sitting in the same group as a bunch of temporary test VMs.
Oh, all right.
Because if someone runs a script to just delete the test environment resource group,
You don't want your entire company's DNS to just vanish with it. That would be a resume-generating event.
it absolutely would. So you create the zone, and right away, before you've even added a single record, Azure gives you 2 things, the SOA record and the NS records.
Start of authority and name servers. Let's do SOA first. This is basically the zone just shouting, hey, I'm the boss of this domain.
It's the source of truth. It has the admin's email, some caching parameters, and crucially, a serial number. Every time you change anything in the zone, that number goes up, so the rest of the internet knows there's a new version.
But the real work, the migration itself, that's the NS records.
This is the handoff. This is what we call delegation.
And this is the part that makes me nervous.
Hmm.
Because until now, everything we've done is just in our own little Azure sandbox.
Yeah.
But this step, you have to go back to the registrar and change global settings.
It feels high stakes because it is. You're literally telling the world, don't ask GoDaddy anymore. From now on, ask Azure.
And I'm looking here, Azure gives you 4 of them. ns1-04.azuredns.com, all the way through NS4. Do I really need to copy and paste all 4 of those?
Yes, do not shortcut this.
Because I've definitely seen setups where people just put the first 2 in and, call it a day.
And they are just rolling the dice. Those 4 names correspond to 4 totally distinct name server clusters. But here's a really cool part. They use something called Anycast routing.
Okay, Anycast. Break that down for me.
It means that ns1-04.azure-dns.com isn't just one server in a data center in, say, Virginia.
Mm-hmm.
That same IP address exists at multiple points of presence all over the globe. So when a user in London queries it, they get routed to the physically closest server in Europe. A user in Tokyo hits one in Asia.
Wow. So by using all 4, I'm not just getting redundancy if one server fails. I'm actually getting a global content delivery network for my DNS queries.
Precisely. It gives you high availability and low latency. If you only list one and the route to that specific Anycast query has a problem, your site goes dark. Use all 4.
Okay, so I've updated my registrar. I hit save. And then, now what? The docs warn about this propagation delay.
Yeah, the time it takes for the new truth to spread across the internet.
Why is this still a thing? I mean, we have fiber optic cables everywhere. Why could it take like 48 hours to update a record?
It's rarely 48 hours anymore, but it's not 0. The problem isn't the speed of the cables, it's caching. Every ISP, Comcast, Verizon, whoever they cache, DNS lookups to save bandwidth. So if they looked up your domain 5 minutes ago and saw the old registrar, they're going to hold on to that answer.
Until the TTL expires, the time to live.
Exactly. You're just waiting for all those caches around the world to expire, so they finally come and ask the new authority Azure for the answer.
So how can I check if it worked without just sitting there hitting refresh in my browser?
You verify the authority directly. Use a tool like nslookup or dig.
I'm a dig fan myself, but nslookup is built into Windows, so.
Sure. You just run a command like nslookup-type SOA wideworldimports.com. You're not asking what's the IP, you're asking who is in charge here.
And if the answer comes back with the Azure name servers, then we're golden.
You've successfully moved the control plane. Now you can actually start pointing traffic.
Which brings us to managing the records. This is the day-to-day stuff. A records, CNE bolts.
The nuts and bolts.
Okay. A record. The most basic. Name to an IP address.
WebServer 1 points to 203.0.113.5. Simple enough. But the real strategic choice here is that TTL you mentioned, the time to live.
The default is usually an hour, 3,600 seconds. Is there a good reason to ever change that?
It's a trade-off. It's performance versus agility. A long TTL means less traffic to your DNS servers, and it's faster for users because the answer's cached everywhere. But what if you need to change that IP in an emergency?
Oh, you're stuck waiting for that cache to clear across the world.
Right. If you have a 1-hour TTL and your server crashes, so you fail over to a backup IP, some of your users could be down for a whole hour.
So the pro tip is, if I'm planning a migration, I should lower the TTL way beforehand.
Absolutely. A day or so before you make the change, drop it to 300 seconds, 5 minutes. Then once everything is stable, you can bump it back up.
Okay, now CNAEs, canonical names.
The alias.
I use these constantly for mapping www to the root domain. So much cleaner than managing 2 separate A records.
It is. A CNAM just points one host name to another host name. www.wideworldimports.com basically says, hey, go look at whatever wideworldimports.com is pointing to.
And if the IP of the root changes, the CNAME just follows it automatically.
Yeah.
But, and this is a huge but, a massive point of friction that I think trips everyone up when they move to the cloud. There's a really strict rule about CNAMEs.
The zone apex limitation.
It sounds so arcane, but it really breaks things.
It's a fundamental restriction in the DNS standards themselves, in the RFCs. You cannot place a CNAME record at the root of a zone. So wideworldimports.com itself can't be a CNAME.
Why, though? What's the technical conflict?
Because the root of the zone, the apex, must have those SOA and NS records we talked about earlier. And the DNS protocol says that if a CNAME record exists for a name, it has to be the only record for that name. So
they're mutually exclusive. You can't have an NS record and a CNAME in the same spot.
Correct.
Okay, so normally you just use an A record at the root, pointed to a static IP.
But
we're in the cloud.
And in the cloud, static IPs are, well, they're passé.
Exactly. I'm using an Azure Front Door or a traffic manager or a load balancer. I don't have a static IP. Azure gives me a DNS name, like my-app.azurefd.net.
So now you've got a problem.
Yeah.
You want to point your root domain to an Azure resource that's identified by a name, but the protocol forbids you from using a CNAME to do it.
What's the workaround?
This is where Azure DNS really starts to flex its muscles. They created a feature called alias records.
This was the light bulb moment for me in the reading. How does it get around that RFC rule?
So technically it doesn't break the rule, it cheats it. An alias record isn't a standard DNS record type. It lives entirely inside the Azure DNS control plane.
Right.
You tell Azure, hey, I want this root domain to point to that specific public IP resource or to that load balancer. When a user from the outside world queries your domain, Azure DNS looks up the current status of that linked resource in real time, grabs whatever IP it's currently using, and then returns that to the user as a standard A record.
Oh, I see. So the outside world just sees a normal A record. The DNS police are happy, but internally, Azure is treating it like a dynamic pointer.
Exactly. It synthesizes the A record on the fly.
That seems incredibly powerful for managing the lifecycle of your resources.
It is, and it solves a massive security vulnerability, something called dangling DNS.
Yes, let's dig into this. Dangling DNS sounds kind of harmless, but the implications are actually terrifying.
It's a subdomain takeover risk. So imagine you spin up a VM, Azure gives it a public IP, you go create a standard A record pointing app.wideworldimports.com to that IP.
Standard stuff.
A month later, you're done with it, so you delete the VM. But you forget to delete the DNS record.
So the record is still there, pointing to an IP address that now belongs to nobody.
For a moment, it's an IP that has gone back into the Azure pool of available addresses. Now, a malicious actor comes along and they spin up their own generic VM. By pure chance, or maybe by trying a bunch of times, they get assigned that exact IP address you just released.
And just like that, my corporate domain, app.wideworldimports.com, is pointing to their server.
And they can host a phishing page, a clone of your login portal, whatever they want, and users will trust it because the URL is correct.
That is a nightmare. And alias records prevent this how?
Because the alias record is tightly coupled to the Azure resource itself, not to the string of numbers that is the IP. If you delete that public IP resource or the load balancer, the alias record sees that its target is gone and it just stops resolving. It cleans up after itself.
That one feature alone seems worth the migration. It removes the human error from the cleanup process.
It forces the DNS lifecycle to match the infrastructure lifecycle.
Okay, so we've spent a lot of time on public-facing DNS, getting the world to your website. But the sources also had a whole section on what they called going dark.
Private DNS zones.
This is for when wide world importers needs its own internal servers to talk to each other without the internet getting involved.
Right. Think of a classic three-tier app. You've got your web tier, your app tier, your database tier. The web servers need to talk to the app servers.
And you could just use their internal IP addresses. Hey, web server, go talk to 10.0.1.5.
You could, but hard-coding IPs in your config files is so brittle. The second you resize a VM and its IP changes, your application breaks. You want to use names. You want to connect to apps-server.internal.
But you can't put that record in your public wideworldimports.com zone because then the whole world can see your internal network map.
Exactly. It's a huge information leak. So you use a private DNS zone. It's a zone that is only visible and only resolvable from inside your Azure virtual network.
The old split horizon concept.
That's it. You can have wideworldimports.com resolving publicly to your website and a separate private zone, maybe private.wideworldimports.com, that only works for your VMs.
So if I try to look up a name in that private zone from my laptop at home,
you get NX domain. Record does not exist. The public internet has no idea it's even there.
the setup looked pretty similar to the public zones, but with one critical extra step: the virtual network link.
Yep, that's the permission model. Since the zone isn't public, you have to explicitly tell it which virtual networks, which VNets, are allowed to see and use it for resolution.
It's like plugging the phone book directly into that VNet switchboard.
That's a great analogy. And on that linking page, there's a little checkbox that is basically a magic button for any DevOps team. Enable auto-registration.
I saw that. It sounded like it completely removes the need to manually manage your internal records.
It does. If you check that box, anytime you spin up a new VM in that linked network, Azure will automatically take the VM's host name and create an A record for it in your private zone.
So if I deploy a VM named inventory-01, I instantly get inventory-01.private.wideworldimports.com that's resolvable by all my other servers.
Instantly. And when you delete that VM, the record gets deleted too.
Again, it's that tight coupling of the life cycle. It really feels like the whole theme here is moving DNS away from being a static text file and into being a dynamic, integrated part of your infrastructure stack.
That's the whole shift. It's treating DNS as code. You know, in the old on-prem days, DNS was set it and forget it. In the cloud, DNS has to be set it and let it adapt.
It adapts to IP changes, to resource deletion, to scaling out.
And that adaptation is what gives you reliability and security. If you try to manage dynamic cloud-scale infrastructure with a static DNS mindset, you're just going to have a bad time. You'll have outages and you will have security holes.
So quick recap of the mission. We started with a domain bought from a registrar.
We created a zone in Azure to be the container. We then performed the delegation by updating all 4 name servers.
Crucial for that global Anycast coverage.
Yep. Then we looked at record types, balancing TTLs for performance versus agility, and we solved that huge Apex problem using alias records.
Which lets us point our root domain at dynamic Azure resources and protects us from those scary dangling DNS attacks.
And finally, we locked down our internal network traffic with private zones and auto-registration so our backend stays completely invisible.
It's a complete modernization of how you should be thinking about naming.
It really is.
I want to leave our listeners with one thought, going back to that dangling DNS idea. It's the kind of quiet vulnerability that keeps security people up at night.
It should.
If you're listening to this and you have a hybrid setup, maybe some stuff in Azure, but your main DNS is still sitting with some legacy provider, do you actually know where all of your A records are pointing?
That's a very valid audit question to ask.
How many of those records are pointing to IPs that you deprovisioned 6 months ago? In a dynamic cloud world, set and forget is just a dangerous policy. It might be time to pull those records into a system that actually knows when your servers turn off.
Absolutely. It's security through integration.
Well, thanks for diving in with us on Azure DNS. Hopefully, your next deployment will have a little less friction. We'll see you on the next one.